Hi, I'm Jamie Turner from SMD, and following some recent queries that we've received into our technical help desk number, we felt it worthwhile preparing this short video on how to use the floor deck design part of our SMD Elements design software. The version I'm using here is version 2.1, which was launched in March 2018, and now I'll just show you how to use it. So you have to have the box here ticked, which is the license agreement and terms of use. So without that ticked, you won't be able to proceed. So we tick that, click the button, and that'll take you into the floor deck software. So on opening the software, you'll appear on this home page interface. The interface for the software is a fairly standard Windows interface. So you've got the file options, references, and about, all with different drop downs, useful links about the software, save, etc. You also have these shortcut buttons, some that take you to the next tab within the software, which is along this tabbed interface. And you have obviously the calculate button and your selection. You can design to Eurocode or BS5950. So in terms of the home tab, the parts that are important for you to input are these parts here, where essentially you're putting in the things like the company name and parts that you want to appear on the header of your calculation. Once you've infilled this area, that will then be the information that will appear on the header of your calculation. As you scan over any part of the software, you can see this information pane at the bottom will give you some guidance on what is required in each cell. On the right hand side of the home page, you also have these three other boxes. One is the changelog. It tells you what's changed in version 2.1 from the previous version. So for example, you can see we've got the TR50 product added in this version. You also have some technical information about things going on at SMD in terms of products and additional design resource. So you can see we've recently launched the White Book Floor Deck Design Guide, which is now available on our website. Just one example of some of the information you might see there. And at the bottom here in the help and support, you've got some links to the floor deck products that are available. That will give you data sheets and properties. Also some further user guide, links to our popular TGN online, where you can get all information on our products and technical backup and guidance, so guidance notes, and then an SCI publication related to composite design. There's also additional tools here where you can report a bug to us, you can suggest us feature, and you can also request a CPD, which we offer to engineers, architects, specifiers, clients up and down the country, and we deliver them every month. So once you've input the information for your design, you then actually crack on with inputting the design criteria and go to the span tab. On the span tab, the first thing you need to do is determine whether it's a single or double span. So a single span being a sheet between two beams, a double span being a sheet over two bays across three beams, as you can see in the 3D image on the top right. You then put in your geometry for your span dimensions. So the default is 3 meters. Should you wish that to be unequal, you can put in an adjacent span number by unticking that box. If we tick the box, it keeps it the same. For the purpose of this calculation, we'll do a 3.5 meter double span. Support width, that's the width of your beams, so 100 being the absolute minimum. We would recommend a minimum greater than that of 120 for composite beam design, but in the purpose of this calc, we'll use 150. You then have the option to turn on or off the auto-calculated construction load. So auto-calculate will work in line with Eurocode or BS5950, which typically is around about 1.5 kilonewtons per meter squared, depending on exactly which code you're using. And you can also introduce propping. If you introduce propping, you'll note that the deck goes to a single span because it's a single span with a prop, which effectively works like a double span. But for the purpose of this calc, we're going to do a double span, no propping. If you were propping, you can choose one line of props or two, and you can also then input your prop width. But for the purpose of this, we're not going to do that. So then, once you've completed your span dimensions and information, and whether you are including propping or not, you can then either click on the Profile tab or click Next, which will take you to the Profile tab where you will select your profile. The Profile tab has changed a little bit in version 2.1. We now have an additional product, as I mentioned earlier, and we also have this extensive information that changes subject to the product that you've selected. For the purpose of this calculation, we're going to select TR60+. As you hover over any part of the software, you will still see this information pane come up, and as you're selecting information, the slab view in the top right gradually builds up. So you can now see we have a TR60 Plus profile across our double span bays. You also see this 2D section graphic through the slab in the bottom right. So I've chosen TR60 Plus. I'm going to choose a 1.2mm gauge, and I'm going to choose a S350 grade for this specific example. But as you can see, each product has different options available, and that is covered in the text below the selection field. So with the profile selected, it's now onto my slab. In determining your slab depth and inputting the slab criteria, you may have already used the white book to give you guidance on exactly what you require. The white book is a quick lookup guide to do concept design of composite slabs. So then you would use the software beyond that for a more detailed design approach. So in the slab pane, you have slab design, slab depth. Obviously, that is the depth of your slab, and as you change that, either by clicking the arrows or typing in your number, you will notice the graphics on the right hand side changing to suit over here. Within there you also have the option to choose composite slab or formwork only. So mostly our decks will be used as part of a composite slab where they form the concrete and then provide the tensile reinforcement in the bottom of the slab. However, you also have the option to utilise them as formwork only, in which case they would just form the concrete and the slab itself would be designed as fully reinforced with additional reinforcement specified within the slab depth. But as I say, typically you utilise the benefit of the decking and design as a composite slab, so that's what we'll do here. I should mention at that point that the TR50 product is a formwork only product, so if we'd have chose TR50 in the profile pane, we would have only been able to choose formwork only. But for the other products, you have this option. The slab condition is determining the fire design. So do we have continuity of the slab? So can we take benefit of mesh continuity over support? So if you see here, I've got a double span slab. So by having a double span deck, we know that the slab has to have continuity at some point, but it could be continuous internal, so it could be a double span in the middle of a greater sized floor, or it could be right on the edge of the building. My recommendation would always be, if you've got a continuous slab, always use continuous end, because every building has an edge, and then you're designing to the worst case for a given floor plate. In concrete details, usual stuff here. You select your concrete grade that you're specifying or you want to use on the contract. You select the weight, normal weight or lightweight. It can auto calculate modular ratio, and I would recommend you leave it as that, but if for any reason you want to change that, you can untick. It will then default to a number and you will need to input that number, and if you tick it back on, it will then recalculate once you get to the loading pane. If I go forward, backwards, you can see it's recalculated. The default densities for the concrete, they're straight out of the code. So interestingly, Eurocode concrete slightly heavier than BS 5950, and you can see these values there. Again, if you wish to change them, you can, but typically you wouldn't need to. We also in here have the ability to input a screed so that it will work out the weight of that in the loading pane automatically, and it will also consider the screed in the fire insulation thickness of the slab when running the design. So to do that, you would just tick it on, put the screed in that you've got, 25 maybe, 50, and leave the screed density or change the screed density to whatever you wish. I'll leave it as 2000 for the purpose of this calc, and that's kind of the specification of your slab done. You can see the graphic hasn't changed because at this point we've only specified that it's a 150 thick slab, what the deck is and what the concrete is within that, but in a minute we're going to see the reinforcement appear. So that takes us to reinforcement, which is the next stage. We have two options at the top: mesh design, fibre design. Fibre design will be coming soon, later in 2018. We're currently working on a number of different fibre options, more than the one tab deck solution that we currently have available, and that will be coming out in the software later in the year, so look out for that. For the purpose of this one, we're going to work with a mesh design, and you have a number of options and input here, so you can tick calculate minimum mesh. That way the software will loop through all the different mesh options, single layers and double layers, to see what the minimum requirement is for your given criteria. But for the purpose of this one, I'm going to purposely use a mesh that I know won't meet the minimum requirement for the code for this design, just to show how that will warn you in the software. So in this area, you also put in the dimension down to your mesh, your yield for your mesh reinforcement, which is typically 500. You can input a single or double layer if you want to specify, rather than use the auto calculate. And similar for bottom bar. Bottom bar is typically only required for high loads, maybe increased slab designs, and also where the slab is single span. So the slab is between two voids, for example, and you will then need bottom reinforcement. But you can put bottom bar in any design if you wish, or if you're using it for another reason. You can then see I've put a 10mm bar and it appears on the image. You've also got your axis distance from the bottom of the profile up to your bar, the yield strength of your bar, so you can see that's 500 as well. Fairly unlikely to change that unless you're in a part of the world where that may not be available. And you can choose 1 or 2 bars as well. So for the purpose of this one, I'm using a double span. Double span design is typically mesh only. Sometimes you need mesh, but not always. You also have the option, so I've mentioned fibers there, that will be the selection field where you can choose the dosage and type of fiber later in the year, and the shear studs. So shear studs can aid in the anchorage of the slab during the composite design stage, so you could turn those on or turn those off, but I would recommend you leave them off unless you're left with having to solve a specific problem, because typically jobs will have some beams with studs, some beams without, so by leaving it out you're just taking the more conservative approach for that specific design. So then after the reinforcement, you're now getting on to the loading. Your slab's built up, so if I go back to reinforcement, you can see now I've got my reinforcement, my slab, and everything that I kind of intend in terms of the slab makeup. Then I put in the loadings that I want to apply to that slab. So in the loading pane, you can see a number are already predetermined, and there's some default values as well. The predetermined ones in grey, the construction load, we ticked auto calculate earlier in the design, so you can see I have the 1.5 there. If I hadn't have ticked auto calculate, I would now be able to edit that field. Although I would recommend 1.5 be used, purely from experience of the kind of loads that get put on decking during construction. We also have a screed load that we'd input a screed, and it works out your kilonewtons per metre squared load for your screed. If we didn't have a screed, you wouldn't see this line appear. The next 4, imposed loads, ceilings and services, finishes and partitions, are just default values for the software, but you can put in whatever you wish within here. You just click in and change the values, and you can also change whether it's dead or live, so you can basically fairly flexible but a typical load grid interface. Down the bottom here you also have the ability to input some point loads, so I may wish to look at a parallel wall, so I can put in the wall type. So we're going to say it's a parallel wall, we'll say it's fairly light, so 3.4 live load, no dead load. If you've got finishes, you put the thickness in there because that affects the spread of that line load. The load width we'll just have 100 in this scenario, and let's have it going across the entire span. So now you can see in the image above the slab is built up, and it's now showing you where I'm considering those loads. You can consider as many loads as you wish, although the more you put on, clearly it will impact on your slab design. But you can choose any type. You can have a point load, which would be your wheel, column base, something like that. You can have perpendicular or parallel line load. So let's just put in a parallel and a perpendicular crossover load. So we'll put this one in as being a bit heavier. Not a great deal. Let's have that as 100 as well. And this one we'll have located 1500 from the left support. If you were to put in a number here that is too close or doesn't work with the parameters, you will see this little red exclamation mark appear, and it will give you guidance on where that should be based to ensure its maximum impact. So by putting this line load over the beam, the line load will be passed through the beam. The software is then suggesting, okay, put this at 275, and that will be the worst case where it's applying it to the slab in terms of the design. So let's put that near to the support for the purpose of this calc. That's the load interface. You can change colors, you can change load names by right mouse button on the load. You can see I could change that load if I don't think the colors to my liking, so I could change it. And there we go, onto the next stage, because the loads are in. Now I just want to analyze, I just want to check the parameters I'm working with. In the analysis pane we have basically all the code defined limits, along with a couple of selectable fields and areas you may wish to work outside the code. So firstly we have the via design method. In there you choose the method of via design you wish to use. There's two methods, the UKNCCI, which uses the mesh and deck, and that's kind of what was known as the simplified method. So it's utilizing the continuity of mesh over supports, so hence why I've used that earlier. I want to use that. The EC standard looks at additional reinforcement, using the reinforcement in the bottom of the slab, and takes no account for the deck during fire. So the NCCI method is very much based on testing that we've carried out on all our products. You can then choose your fire rating in here, so half hour up to 2 hours. An interesting point is that Eurocode doesn't have data for 4 hours, so if you want to do a 4-hour design, which is very uncommon but does happen, you would have to use a BS design at this point in time. So for the purpose of our calc, we'll do 1 hour. Partial load factors, you'll all know those from BS before. These are the Eurocode ones. You could change them if you wish. I'd see no reason to. You also choose your load category, so you've got office, residential, and as you change that category you will notice that these values, these psi factors, change, and that is taken into account in the fire design, so it's the factor that applies to the fire design load. So for the purpose of this I'm going to use residential, and you can see the factor is 0.5 is what's going to be used in the calculation. Deflection limits, all as per code. You can change them should you wish, so that gives you some flexibility in your design. And last but not least is the longitudinal shear method. So that is two methods of longitudinal shear design in Eurocode, M&K and partial interaction. Or I would always recommend the partial interaction method. It's just a bit more of an intuitive approach and better when we look at the results in a moment. So without further ado, you would then press calculate. So as I said earlier, I was expecting this one to fail. The mesh doesn't meet a requirement of the code, and there's a number of this types of message in the software. It may warn you on not meeting the fire insulation thickness, it may warn you on the mesh minimums not being met. So this, as you can see, is a point that the mesh doesn't meet the minimum requirements set out in the code. It gives you a clause information, and it also tells you what the minimum is, so that's the calculation. So we need 180. So then it's taken me back to the tab where I can change this. So if I had ran auto calculate, it would have auto calculated to A193, but it's telling me I need to have 180. So if I put 193 in, click calculate again, and you can see it's taking me now to the summary screen. Having looked through all the tabs on the input software that you see in the background, we're now on the summary tab of the output of the software. So the summary gives you all three stages of the design: the construction stage, the composite stage and the fire stage, and just some quick lookups to see your unity factors and whether the result is a pass or a fail. Tick being good, red cross being bad. And it also gives you the max unity factor, and in the bottom of the software here you can just see a summary of what you have specified or designed to that point. You can then print from here and you can export to Word, but that will print and export the report, which is a more extensive version of the summary screen, giving you the applied values, the capacities, all your input criteria. It also gives you a useful section here showing the slab that you've actually specified and designed, and yeah, something that you can then print out. There's a number of notes at the bottom which should be read, but basically reference to stuff that I've kind of mentioned in this report. And you can also export that to Word should you wish here. So the other things that are quite useful when just reviewing your design are these 4 other tabs, and they're there just really for reference diagrams. They don't print, but they're there if you want to kind of understand your design a bit better. So these are all for the composite stage. They give you your applied moment, so we had UDL and fairly consistent loads. so you can see the bending moment applied. It also gives you the moment resistance, and this being a partial interaction design, the moment resistance goes up as you go along the section and there's more of the profile in connection with the concrete. You also have the vertical shear check, so you have your shear resistance and where they apply. We had the point load that we put, or not the point load, sorry, the perpendicular line load that we put near to the support here, so you can see the shear force diagram, and again deflection as well. But generally composite stage deflection will not fail the profile. It will be the deflection during construction or the design during construction that typically governs the profile design. You can also see load spread here, so if you've applied a line load or a point load, you can have a look at the width of the slab that is being used to resist that moment in accordance with the Eurocode or BS 5950 as it's designed. That's quite useful if you want to put a line load near to a unsupported edge or put line loads in close proximity to each other, because you can actually see how much of the slab is being used to resist the load. So that's quite a useful function. But in principle, the most important part, if you're wanting to run your design, get the design out and print it out for you to then use in your product or project, should I say, specification, this is the one. You would then print that to PDF, and hopefully we would see it at tender stage, price it, and hopefully get to work on that contract in the future. If you have any queries relating to the software, then there is the option back on the home page to suggest a feature or report a bug issue. That will also email the technical help desk. Alternatively, you can ring us in the office. We have a technical help desk who are here on hand to advise with calculations, and I hope this has been of assistance. Thank you.